Now that we've looked at the relationship between percents, decimals, and fractions, we'll start working with the percents. So the first thing is that we can find any percent of a given number simply by changing the percent to a decimal and then multiplying, right? So like 100% we had mentioned is really just 1. So 100% of a number is just the number itself because it's 1 times the number. And then 200% of a number would be 2 times the number, right? So twice the number. 300% would be 3 times the number, so on and so forth. So 100% of 50 is just 50. 200% of 50 is 2 times 50 or 100, so on and so forth. All right. Now this is over of equals percent over 100 proportion. I know a lot of people use this from, high school, middle school type stuff. Don't like that. So please don't use that. The equation that we're going to use with percents is this percent equation, A equals P times B, which is going to stand for amount equals percent times base. So that's really the equation that you should always go to when you're trying to do percent problems. Now, some of these problems can be done by using mental math, though, as long as you remember our percent fraction equivalences, right? Remember my nerd table that I had created the last time? So the first one is there's an easy way to find 10% of a number, and this is the one that like everybody knows basically, right? What do you do to find 10% of a number? You're basically just moving the decimal point 1 to the left, right? So how do you find 10% of 895? You just do one place to the left, so it's 89.5. What's 10% of 27? One place to the left, so it's 2.7. What's 10% of 10,411? 1041.1, right? And why does that work? It works because 10% is 1/10, so you're really just dividing by 10. And remember when we did the decimal unit, right? We had talked about when you divide by 10, you're just moving the decimal point 1 to the left. Okay, so that's what you're doing when you take 10%. You're just dividing by 10. But in addition to 10%, there's also easy ways to find 25%, 50%, 33 and a third percent, etc. of numbers, right? So just think about it. So like if I said, what's 25% of uh, 40, for example, right? What's 25% of 40? Well, we know that that 25% is really 1/4. So what you're really thinking here to yourself is you're really just thinking, all right, well, I'm really just doing 40 divided by 4. Why? Because 25% is really 1/4. So you're really dividing by 4. So 40 divided by 4, so you just get 10. So if I said, what's uh, 50% of 80, same idea. What would you think here? You'd think to yourself 80 divided by 2. Why 80 divided by 2? Because 50% is 1/2. So you're really just doing 80 divided by 2, and 80 divided by 2 is 40. Okay? So that's what you do to find like 25%, 50%. And then even something like, what's another good one? Like say we were going to do 75%. What's 75% of 60, for example? Well, what we would do is we would think 75% is really 3/25s. So what you're really doing here is you're really doing 60 divided by 4, but then multiplying that answer by 3, right? Because 60 divided by 4 would give you 25%, but then you're taking 3 25%, right? And again, why does this work? Because 75% is really 3/4. So that's where the dividing by 4 and multiplying by 3 comes into play. So if I divide by 4, I get 15, and then 15 times 3 is 45. So 75% of 60 is 45, right? So that's useful if you can do that kind of mental math stuff. And then the little note here is when you're given the is part of a problem, instead of the of part, you really do the opposite. So instead of saying, what was the first one? What's 25% of 40? If I said uh, 40 is 25% of what? This is the reverse, right? Because in this case, I know the 25% amount, but I want to find the whole amount, right? So 40 is 25% of what? So here I would actually do 40 times 4, and I would get 160. And there's a nice way to think of this if you think in terms of our fractions circles that we had done, right? If you break up this fraction circle into quarters, right? 25%, 25%, 25%, 25%, 25%, 25%, 25%. In this case, the 40 isn't the whole. The 40 is one of these quarters. So if you have a 40 in this quarter, that means you have a 40 in this quarter, and a 40 in this quarter, and a 40 in this quarter. So when you have four 40s, you get 160. So that's another way to do that with mental math. All right. Now, if you don't want to do mental math, if you say, that's a little too confusing for me, you can always just use this percent equation. Okay. And this percent equation, A equals P times B, it stands for amount equals percent times base, right? Amount equals percent times base. And it depends on the type of problem you're dealing with, right? So the amount might be a part, right? It might be a part of the whole. It might be the change. It might be an increase or a decrease. It might be a discount. It might be a markup, or it might just simply be like the is part of a problem. And then the base can be thought of as the whole, the original amount, the regular price, the cost to the seller, or the of part of a problem, right? Again, it depends on what kind of problem you're dealing with. So it takes a little bit of practice. You got to get used to these different kinds of problems you get, like discount, markup, and percent change and things like this. And then one little note that I make here is it's important to remember this. Note the amount is not always less than the base, right? The amount is not always less than the base. Whenever the percent is greater than 100, the amount is going to be greater than the base. So just keep that in mind, because you tend to think of a part as always being less than a whole, but a part could be greater than the whole whenever the change is more than 100%. Okay, so if the change is greater than 100%, if the percent is greater than 100, the amount is going to be greater than the base. So the thing is, when you're doing very simple problems like just something is something percent of something, you don't even really need to use the A equals P times B. You can basically just do a direct translation. So what do I mean here? What I mean is just read this example. 36 is what percent of 42? So you just start writing this as an equation. So 36, we had said in that first unit that is means equal. What percent? So that's the unknown. So that's going to be our P. Of means multiplication, 42. So 36 equals P times 42. And I would just solve this by dividing by 42. So I would end up with P equals, and then 36 over 42, just punch it in the calculator. So 36 over 42 is really 0.857, I guess we can say 0.857. So it's 0.857, but this is in decimal form. So if we want to turn this into percent, remember what we do with a decimal? We move it 2 to the right. So we would get 85.7%. So in this case, we actually have to round that. I mean, there is a way to turn it into an exact percent, but we're not going to do that. We'll just round it. So 85.7%. And then similarly, what number is 28% of 67? So what number, that's going to be the A, is means equals 28%, I would write as 0.28 of means multiplication 67. So this one, there's no equation solving steps to do. It's just basically multiplication across on the right side. So if I would do 0.28 times 67, 18.76. Okay, so there I was solving for A, and then in this last one, I'm probably going to be solving for B, right? So if I start doing my translation, 23 is 126%, which I would write as 1.26 of meaning multiplication. What number in this case is the base, right? So it's A equals P times B. And then I would solve this by dividing by 1.26. So I would have 23 divided by 1.26, and 23 divided by 1.26 is, again, it's just a decimal that I'll round, I guess, 18.25. So it's 18.25. Right? So the B in this case is 18.25. So that last set of problems, we really didn't even need to think in terms of the A equals P times B percent equation. We really could have just done them by direct translation, right? Like turning the sentence into an equation. But it's not always going to be so obvious what's the A and what's the B by just doing a direct translation. So what you're going to have to do is you're going to have to try to determine in most of these problems which quantity represents the whole and which quantity represents the part, because the whole eventually becomes the variable b and the part will eventually become the variable a. So you know that when you go into these problems, you're going to be writing your equation a equals p times b. The p is always going to be easy to spot because it's just going to be a percent, right? So an orange juice producer makes its product with 45% water. So there's your p, 45%. If a carton of the juice contains 64 fluid ounces altogether, and again, this is the key word here, altogether, how much of that is water? So in this case, the water is going to be the part, and the 64, right, is going to be the whole, right? Altogether meaning whole. So the 64 is going to be your B, and in this case, you're trying to find the part that is water. So you're trying to find the A, and of course, as we said, the P is 45%. So in this case, now we have A equals P times B. A is the unknown, so just leave that as A. The P I'm going to replace with 0.45, and the B I'm going to replace with 64. So I would just do 0.45 times 64. 28.8. So this is 28.8 fluid ounces of water. So that would be how much water is in that carton. All right. And then another one, the population of Tinton Falls is 15,053. And if that is 3.3% of the total population of Monmouth County, what is the county's population? So in this case, the 15,053, that's just this one town, because we're considering the whole as being Monmouth County. So this Tinton Falls population is just going to be your part, and the total population of Monmouth County, that's going to be your whole or your base. So the 15,053 in this case, that's your part, because that's just a little piece of the whole county, right? 15,053. And then, of course, the 3.3% is just your percent. Okay, so if I write A equals P times B, now I just start filling in. Well, in this case, I know A is 15,053. P is 3.3%, which is 0.33. And the base in this case is the unknown. So then I would just divide both sides by, oops, it's not 0.33, it's 0.033. You gotta be careful there, right? 0.33 would be 33%. This is 3.3%. I had to move 2 places to the left. That's one of the key mistakes people make, and I just made it myself, right? So it's 0.033 times B, and then to solve this, I would divide by 0.033 on both sides. So 15,000 divided by 0.033. So I'm going to get that my base, which is my total population of Monmouth County, is, just go to the nearest person here, right? Nearest one. So 456,152. So 456,152. That's my county population. So in that case, I was finding the base. And then in this last one, a homeowner is selling his house for $325,000. It was originally purchased for $255,800. What percentage of the original price is the selling price? This one is a little bit different because you want to think of the original as your base, right? It was originally purchased for $255,800. So you're thinking of the starting value, right? That is going to be your base in this case, and your selling price, that's going to be your amount. And then you're trying to find what percentage. So the P is the unknown in this case. And again, this is one that you actually could have probably just done a direct translation on. If you look at this last sentence, think about it. What percentage, so P times the original price, which is 255,800, is the selling price, 325,000. right? So if you just take that last sentence and convert it into an equation, it works. But we also could have thought of the A as being 325,000. There's the A, and then the uh, B as being 255,800. There's the B. Okay, so how would I solve this? I would just divide by 255,800, and then I would end up with 325,000 divided by 255,800 is 1.27. So it's 1.27. But remember, that's in decimal form. That's not in percent form yet. So it becomes 127%, right? And why did this work? This was an example where it's greater than 100% because the amount is bigger than the base, right? Remember I had said that at the beginning? Whenever the amount is bigger than the base, the percent is going to be more than 100. So in this case, yes, A was greater than B, so the percent was greater than 100.